All right, filling in the rest of the unit circle. So last part of section 1.4. So we had previously filled out this first quadrant of the unit circle. We have our pi over 6, pi over 4, pi over 3 angles, which are the 30, 45, 60 angles. We have the coordinate points there. I went ahead and left these coordinate points here too. But we have the rest of the unit circle that we can now fill out, and it's not bad. It really isn't. So here's the thing. Here's the thing. We got this side right here, this 30-degree angle, and it has the coordinate point square root of 3 over 2 comma 1/2. Notice, notice over here. So this is a 30-degree angle, and then look, if you have 150 degrees, its reference angle will be 30 degrees right here, right? This is 30-degree reference angle, which means that this coordinate point right here has these values, but with different signs. So it's going to be square root of 3 over 2 comma 1/2. In quadrant 2, x is negative, y is positive. In quadrant 3, they're both going to be negative. And in quadrant 4, x will be positive and y will be negative. In quadrant 1, they're both positive. So this guy right here, I'm going to finish off the coordinate point for in a moment. It's just that same value, but he's negative. The x value is negative, the y value is positive. It's the same point, just this guy's negative. Notice as well, this 210-degree angle. This is also going to be a 30-degree reference angle. There's 30 degrees between 180 and 210. So he'll also have this same value, but both x and y will be negative. So let me just boom, move him a little bit further away and make him negative. And you can kind of see where this is going, yeah? Over here, 330 degrees. 330 degrees is 30 degrees away from 360. So his reference angle is 30 degrees. It's going to use the same x and y values, but now x will be positive and y will be negative. So I'll just erase the negative sign, move that over, boom. Right? Notice for all of those, for the radian measurement, those were all pi over 6. All the pi over 6 angles are root 3 over 2 comma 1/2 with different signs. For the 45-degree angle here, we had the value root 2 over 2 for x and y. If you come over to quadrant 2, 135 degrees. 135 degrees is 45 degrees away from 180. So the reference angle for 135 is 45 degrees. That means that the 45-degree angle here and the 45-degree angle here, they'll have the same values, but different signs. So it'll be some form of square root 2 over 2 comma square root 2 over 2. But the x value in this case will be negative. Notice that these are the pi over 4 angles. That's going to be true of 225 degrees, which is 5 pi over 4, and 350 degrees, which is 7 pi over 4. Those are all going to have 45-degree reference angles, and therefore they're going to have the same value with different signs. I'll just duplicate this guy, duplicate, duplicate, and I just need to fix the signs on him. In quadrant 3, I know that both x and y are negative, so I'll put a negative sign in there. And in quadrant 4, x is positive and y is negative. All right, looking then at these pi over 3 angles, right? You can see the pattern that's happening here. All of these pi over 3 angles, they all have 60-degree reference angles. The distance between 300 and 360 is 60 degrees. So this is a 60-degree angle. This is a 60-degree angle. 120 to 180, this whole thing is a 60-degree angle. 180 to 240, that's a 60-degree angle. They all have 60-degree angles. So they're going to use 1/2 comma square root of 3 over 2. In quadrant 2, x is negative, y is positive. Let's see if I can, boom, duplicate. I'm going to pull this down to all of the quadrants and then just fix the signs. So we are good here. This is solid right there. In quadrant 3, they should both be negative. In quadrant 4, x should be positive and y should be negative. And then the only thing that's missing, this point right here is the point -1 comma 0. It's on the coordinate system. And then this guy right here is going to be the point negative or 0 comma -1. 0, -1. I'll highlight those in red. And there's that. There's filling out the unit circle. I want to talk real quick about memorizing these. So I like to think of these in the radian form because it's very clear which angles match up together. The pi over 3 angles match up, the pi over 4 angles match up, and the pi over 6 angles match up. And I have this picture here. Normally I do this in front of a class, so I would be doing this with my hand. So do this with your own hand here. Thank you, Google Stock Images. We're looking at quadrant 1 right now, and I want you to think of your hand as having these 3 spokes that exist in quadrant 1. So these guys right here, right? These are those middle fingers. This is your thumb. This is your pinky. So this is pi over 6. This is pi over 4. And this is pi over 3. This is 0. And then up here is pi over 2. And the way that this works is when you put down a finger, you're left with a certain amount of fingers on either side of that finger up. So for instance, if I were to put down my pi over 3 finger, let's see, let's do that with like, I don't know, white maybe? No. What color is going to be good here? I'll just use blue. All right, let's say we put down this finger. This finger goes down. So this finger goes down. What you're left with is your thumb up and then these 3 fingers over here up. And the way that this works, you have an X value, you have a Y value. You're going to take the square root of the number of fingers on the right that are still up, or the left that are still up, divided by 2 for the X value, number of fingers left on the right side of that finger that you put down divided by 2. Because look at these values. These values right here, they're all over 2. They're all divided by 2. And really, they're all square root, right? Square root of 1 is just 1, so we don't put it there, but right, square root 1, square root 2, square root 3. Square root 1, square root 2, square root 3. Oops. Oh, close enough. Scrolling down. All right. So if I put down that pi over 3, I would have, let's use pink, right? I would have 1 thumb left on my left side. So one thumb left. Boop, boop, boop. So it's square root of 1, and then everything is divided by 2. On the right side, let's use red or maybe green. We'll use green. On the right side, we have 1, 2, 3 fingers left up. 3 fingers. So it's square root 3 over 2. So you can see it, right? So for the angle, pi over 3, the coordinate point is, we can take rid of that square root there, 1/2, comma, square root 3 over 2. Is that right? 1/2, square root 3 over 2. It works for all the angles. It's a really nifty trick here. So if I just kind of erase, boom, 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 all of those, let's look at pi over 6. If we put down the pi over 6 finger, we know all of them turn out to be square root of something over 2, comma, square root of something over 2. For this one, 3 fingers left on the left side and 1 finger left on the right side. So for pi over 6, the coordinate point should be square root 3 over 2, comma, 1/2. Square root of 3 over 2, comma, 1/2. It actually even works with the thumb and the pinky as well. So if we do it that way, it's actually quite interesting. Let's see. If you put down pi over 2, there, and we still use this square root over 2, square root over 2. If you put down this guy, there are no fingers left on the left side. And there are 1, 2, 3, 4 fingers left on the right side. And I guess this guy should have been a green one right there. So the square root of 0 over 2, that's just 0. Square root of 4 is 2. Divided by 2, that's just 1. So the coordinate point at pi over 2 should be 0, comma 1. And indeed, 0, comma 1. Anyway, it's a fun, nifty trick. Great for memorizing. And that's all I have for this section. So next section, we're going to be talking about graphing, which is a ton of fun. I'll see you in that video. Bye.